Welcome back to the Numpy Part 3 tutorial, guys. So in this tutorial I'm going to talk about broadcasting and structured arrays in Numpy. So before going through the topic, so I want to tell you guys something. So if you have not watched my Numpy tutorials part 1 and part 2, then I highly recommend you go and watch that tutorials, because there are a lot of things that are pretty basic. You need to understand those topics before you actually understand what broadcasting and structured array is. So I highly recommend you go and check that tutorial. So I have all these notebooks in GitHub, so I'll post the link to the GitHub in the description below, so you don't need to worry about it. So let's just get started with broadcasting. So if you want to learn more about Numpy, Python and data science, machine learning and so on, then please don't forget to subscribe to my channel, because it helps me a lot to produce new upcoming videos. So it will also help you to learn something new. So don't forget to subscribe, like, comment and share the video. So let's get started into the actual content, guys. So what is broadcasting? So the broadcasting, as documented by this original documentation here, it describes how Numpy treats array with different shape during arithmetic operations. So see here, let's consider example. So I have a here. This is the Numpy variable. So I have an array that has 3 elements in it. So another array there here, and in variable b here, and 3 element in here. So these two are just same size. Okay, so the operation is obvious, so the result is obvious that it will not throw any error in here. So but you look at here, so here this array, the size of this array and thus this element is different. There are 3 columns, but here is only one scalar, that means only one column. But also the operation, the mathematical or arithmetic operation between those are compatible, so there is no any error thrown here. So this is possible because of broadcasting. So I think that is enough introduction for broadcasting. So you can also read another definition or to understand about broadcasting here. So broadcasting refers to smaller ranked multi-arrays being either replicated or extended in a natural way to work with higher ranked multi-arrays. So that means you can look here. So here is only one value here, the size of this array is 1. So this will actually extend into three element, and each 3 element in an array, but all those element in that array will be 2. So this and this will have same size, and this will be compatible. So you will also see another examples later on. So let's get started into actual code. So smaller array is broadcasted into larger array to perform the arithmetic or any kind of operation. So the first thing I want to do is import Numpy and namespace it. So basically I want to clear all these cells before I want to show it. So the first thing is import Numpy and alias it. So I have imported it. So I want to create a 3-dimensional array here. See, this is a 3-dimensional array variable, and I have used the arrange function here to create the elements of 70 here. So size is 70. So and I have saved it into the 2 group of matrices, each of 4 row and 5 rows and 7 columns. So if I execute this code here, you can see here 0, and the starting element is 0 and last element is 69 but not 70. I have already discussed about this in my previous video, so you need to watch that if that is confusing to you. So the shape attribute basically sets the shape of this linear array into this 3-dimensional array. So the first thing I did was that created a 3-dimensional array variable here. So before understanding Numpy's broadcasting rules, so basically you need to understand some of these methods, how they work. So let's get started. The shape attribute here, if you execute this, it will basically return the dimension and row, column and all that stuff. So this is not so surprising that it has 2 rows, 5 columns, 2 group of matrices and 5 rows and 7 columns, since we have explicitly set here. So this basically gives the shape of this array. So if you want to find the dimension, how many dimensional matrix or array is this, then the ndim, this is the method that helps you find out that. So this is a 3-dimensional matrix. So three types of matrix or array, so you can basically get the result here. So one way to find out how many dimensional this array is to count this square bracket. So 1 2 3, you can see here 3, so it is a three-dimensional numpy array. So if you use the size attribute here, it will basically return 70. This is because it has 70 elements in here, so this is also not surprising since we set here 70. So you can see here, if you want to find the data type, so you can just do d type here. This will basically return here integer of 64-bit because we have all the integer in here. So this is actually an example of broadcasting here. So you can, if you execute this code, so this is actually scalar. Look at here, this is a three-dimensional array, but this and this is a scalar. So broadcasting made this possible, of this operation possible. So this 5 has been stretched into the three-dimensional array of this size, okay, of this size, and each element of this size has element 5 in there. So this and this has the common size, and the same thing goes on with this. But one thing to notice here is the numpy internal working does not work that way. It does not actually create 5 5 5 5 5 in here, so as this, but it is clever enough to just perform the operation that way and return the result. So you can see here the result does not give error, and this is because of broadcasting rules. So broadcasting made this operation possible. So here 5, this is scalar and three-dimensional array, so operation is successful because of broadcasting. So the another example I want to show you is I have created the first array here and created 20 elements in that array and reshaped it into 4 row and 5 columns. And you can see here second array, so let's execute this one. So here second array, so I have created 20, and but the shape here is, so the reshape operator, the reshape method does here is, so it sets 5 rows and 4 columns. So let's also execute this. If you want to see the output, then you can basically type the variable and it will just return the output. So if you want to create a arithmetic or product, say if you want to create the product of these two matrices, then if you use np.inner method, so np.inner and these two numpy arrays, so if you execute this, it will actually give an error because it will complain that the dimension is not aligned, so the shape is not aligned. So you can see here the difference between the inner product and dot product. But if you just execute this dot product here, then the operation is successful. So if you are confused in this, you can actually basically see in here. So if you use dot product, this is for two-dimensional array. So for two-dimensional array, it is equivalent to matrix multiplication. And if you want to see here, it is the inner product for one-dimensional array. So the basically a conclusion is that if you want to perform some types of complex method in NumPy, then you are just advised to look at the documentation and just find what is right for you, so you won't be surprised later when you find the result. So if you want to find the product for two-dimensional array, then you should use dot. For one-dimensional array, the inner will work, but you can also use dot. Okay, so if I print out the three-dimensional array here, so you can basically get that. So I want to perform the sum of these all elements inside this NumPy array, then you can use dot sum method here. So if you execute this code, you can just see here 2415, this is the sum of elements from 0 to 69. Note that you can also find the sum of the elements from 0 to 69 by using formula n into n plus 1 by 2. So if you do 69 into 70 by 2, then it will basically return a floating point result. So this will return 2415.0, but this array here, it just returned the integer value. So the next thing I want to show you is along the axis, broadcasting along the axis. So see here the three-dimensional array, I want to perform the sum but in axis equal to 0. So if we execute this code, then you can see basically here, so 0 has been added to 35 and 1 has been to 36. So you can see here the result has been printed, so on. So if you just do that, axis, this is for axis 0 in three-dimensional array. So if you want to perform the sum along the axis 1, then you can basically see here the 0, 7, 14, 21, 28, and the sum goes here. So the here and all these elements here over here, this sum goes in here. So as on, so this has been as executed. So if you perform the operation on the axis 2, then basically you can see here, so the sum has been performed the horizontal wise. Okay, so you can see here the results. So the basically the conclusion is that, so if you broadcast along the 0th axis, then we eliminate the 0 element in the shape attribute. Okay, see here now, 0th element in the shape attribute. Okay, see here the shape of this array here. So let me execute this first. So two group of matrices, 5 rows and 7 columns. So if you perform the sum operation along the axis 0, then this 0th element in this shape will be eliminated and the result will be 5 row 7 column. So 1 2 3 4 5 row, 1 2 3 4 5 6 7 column. So if you perform the operation along the axis 1, then this element will be eliminated. So 2 rows and 7 column. You can see here 1 2 rows, 1 2 3 4 5 6 7 row column. So if you perform along the second axis, then this element in the shape attributed will be eliminated and 2 row and 5 columns will be the result, as you can see here. So this axis is very important in Numpy, so you will basically use a lot in your data science career, so you need to be careful about it, and you just download this notebook and just play around with it if you are not comfortable. So I think I have another example in here. So you can see here, for two-dimensional array I want to show you. Okay, so I have imported the Numpy because this is basically a console. I have not imported it, so I have created the Numpy array here and arranged it into the 16 elements in the Numpy array. So I have received into the 404 columns, as you can see here, 404 columns and 16 element in here. So along the axis 1, axis 0 for two-dimensional array, you can see here the first element of this shape has been eliminated, and this 4. So it has basically created the 4 column row column. So row has been eliminated, so it will just return the column. So 4 columns in here. So as similarly for axis 1, you can also perform so on. So you can see here, so if I perform the operation along the axis 0, then the first element here, the row, is going to be eliminated and arithmetic or sum operation is going to be performed along the column. So if you just put here 0, so it will basically do into the column, so column wise sum, so it will pre-produce the column wise sum. So if you perform the broadcasting along the axis 1, then axis 1 means this will get eliminated, and look here along the row, so row column, along the row will be operation performed. So here, so 3 2 1 3 and 6 here. So this is how it works. Okay, so you can see here how two-dimensional array in axis works. So this is basically same as this. So here also the operation has been performed the same way. So this is actually a shape attribute. So I want to give one more example on broadcasting here. So here I have an array 1, so created array 1 and 36 element, reshape it into the 6 row 6 column, execute this. So I have not printed the output, so I have created another array here. So numpy array dot np.random basically gives the random output here. So 72 random numbers here. So and reshape into the three-dimensional array, two group of array, so each of 6 row and 6 columns. So if you execute this, it will basically create the array. So I want to perform the plus or addition operator between those two arrays. So if you execute this, then the result, so if you just want to print out the result, then you can basically print the result. So you can see here the operation between the two-dimensional array and three-dimensional numpy array has been performed successfully because of the broadcasting. So let's do another thing. So I have created another divider variable here. So np.arrange plus 6. So this will create the numpy array 0 1 2 3 4 5 and with each element it will add 6. So 0 plus 6, 1 plus 6, 2 plus 6, and so on, and it will create the array. Okay, so I have used here set print options here, so this will basically set the precision before producing the output. So when you just print out the, so I have used the divider and divided it by this numpy array. So this is also possible because of broadcasting. So I have not executed this, so it is throwing me error. So I also need this to execute. So if I execute it, so you can see here the operation has been performed successfully and the precision is 2 after the floating point, as you can see here. You can also set the higher precision like in here, so this basically works that way. So the next thing I want to discuss is structured array. So if you have never worked with structured array, then this is basically like a spreadsheet. So a spreadsheet has age column and it is integer, and another has name column and string of 6 character and so on. So it is basically like a spreadsheet and it works in numpy. So if you execute this, so I have created this data definition. So I want to create the data definition of that has age and name attribute. Okay, so if you print this out, so you can see here the list here contains the two tuples here, then the tuples has the data definition in here. So I want to create a numpy array and I want to create the zeros and 4 zero element, but of data type not integer, not float this time, and our custom data type here. Okay, so if you execute this, then basically you will get the array. So if we want to see what the results look like, so you can see here the first element here, so you can see here age is 0 because this is integer. So string, so name here, so there is basically nothing in the string, so it is just empty string. So another is same, another is same, another is same. So basically this is returning the 4 in here, so because we have declared 4 here and we have created the zeros. Okay, so this is the result. So I want to put the third element in here as my age is 22 and my name is Robin. So I have just used this, and if you execute this and print this out, you can see here my name, my age and name has successfully been added to the numpy array. So if you want to work with the complicated type of data type, so then you can basically use the structured array. So you can also create the multidimensional structured array. So I have created the same type of data definition here, so basically the dimension is higher. So if you execute this and if you just print this out, so you can see here age and string and so on of 4 groups matrices, 3 row 3 columns. So if you want to print the some types of some particular attribute or some particular value of this, and you can basically use this row, column and group of matrix. So if you want to just change the value, then you can simply do this. We have also discussed it in the previous videos too. So you can see here 32 zone has been added to the numpy array. So if you want to just find or just extract the age from this structured array, then basically you can pass this parameter in here, because we have previously set it as our data definition here, you can see here. So if you execute this, then this will basically just return all the ages only. So all the ages is here, so you can see here previously we said 32 and it is in there. So if you want to print just both of them, then one thing to notice is here 2 square brackets, so age and name. So you need to pass to a list in here, so list of attributes as an argument, okay, our parameter. So the next thing I want to discuss is record array. So record array is same as structured array, but the one thing is you can just append this attribute here to get the result, but you cannot dot to their dot age and get the result in this structured array. So you can see here, so the way of creating a record array is my record array equal to np.record.rec.array. so you can see here I have just put the data here. So and data type is data definition. This is basically a one element in here, so in array, so just one element 36 Jagma. So if you just want to find the age of Jagma, then you can just basically pass the index of that element and just attribute you want to watch out. So if you execute this, and you can get 36 element in here. So this is how the record array and structured array works. So if you, when you are just confident with working structured array, then I highly recommend you go with record array. But if you are not confident with structured array, then it may be little confusing as a beginner. So that's it guys. So thanks for watching. If you have any questions, then just comment in the below section, so I will just be happy to respond you. So thanks for watching. Don't forget to subscribe guys. So bye.